Hi class, welcome back. The exam number 3 review part 2. So in this video, we're going to work another set of the 3 or 4 problems on the exam number 3. So last time on the part 1, we stopped at the problem number 3. So today, we're going to start at the problem number 4 here. Okay, so here, let's take a look at the problem number 4 here. Okay, so the problem number 4, they tell you a jar contains a 4-color bowl. Okay, so a jar's here. So in this jar, they have 4 different colors. They have the red one, and then they have a blue one, right? Then they have a yellow one. So they have a yellow one. And then they have green ones here, right? So they have yellow and the green ones here. So in this is the first jar. Then the second jar here, it has the numbers here, right? So the second jars here, they say, the contain the 5 balls, and then the labeled 1, 2, 3, 4, 5. So they have 5 balls here. So this one is 1, 2, 3, 4, 5. So they have the numbers on those balls here. Okay. So the experimenter will tell you is take out 1 ball from the first jar and then take out a ball from the second jars here, right? So we got to take 2 balls. One is for first one, one is for second one. So the first one, they say, find the sample space. Okay, so the sample space here, right now, this is going to be a pair data, correct? Because I'm going to have a first ball, then I'm going to have numbers, right? Okay, so that's once here. So let's see here. So we're going to have first, so let me write this way. So the first ones here, I can get a red ball here, right? So I can get a red ball. So I can have a red. The first draw is a red ball. So I can have a red, 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 red. And then the second ones here is a number. After you draw a red ball, I could have a 1, 2, 3, 4, 5, right? So the same way, I could draw blue ones here. Right, so I can have a blue balls here. So I can have a blue, the first draw is a blue, and the blue. Then after I get the first draw, my second ball can be 1, 2, 3, 4, 5, right? So the second one's, then we also can draw a yellow ball here, right? So let's take a look at what is my yellow balls will looks like. My yellow balls here, I'm going to have a first one is yellow, 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 yellows, right? And then my second one can be 1, 2, 3, 4, 5, right? And now the next ones here, I can have is what? The green ones, right? So I have dot, 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 dot. So the first one I can, and the next one I can have is the green. So it's green, 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 green. Then the second ball here could be 1, 2, 3, 4, 5 here, right? So this is my total sample space, right? So the total sample space. So how many elements I have here? I have 20 elements here, okay? So then the second ones here, they say, the part B, they say, event A is the first ball, is the red one, right? So event A is the first one, first ball is a red ball. So what is my event A going to be? My event A going to be what? The first one is red, right? So how many I have? I have 5 of them. Right, so I have red, 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 right? So that's what is my event A here. Okay, so then the event B is here, part C is here. Let's say the event B is the second ball, is an even number. All right, so now let's write down the event B here. Second ball is an even number, so that means that they could be all 4 colors, right? But it's an even number. So it could be 2, 4, 2, 4, 2, 4. So the second ball is an even number. And then I can have a red on the first one, red, red. Then I can have a blue. I can have a blue, blue. Then I can have yellow. So I can have yellow, yellow. Then I can have greens, right? So here, this is my green, green. All right. So now I know my A. So total here, how many, what is the samples here? So total here, how many I have? I have 20s, right? So total, how many I have here? I have 5. So total, how many I have here? I have 8, right? So part D, they said, what is the probability of the A? And that's pretty simple, right? You just use the how many A's you have over the total number. So it's 5 over 20. So it's 1 over what? It's 1 over 4. Then what is the B's here? B is A over 20s, right? So then if you simplify a little bit, so it will be 2 over 5, right? So that will be the probability of A and the B. So as long as you write it out, the sample space, and then write out each event, then it's pretty straightforward. Okay, now let's take a look the next one, the problem number 5 here. So when we try to do the problem number 5, for this type of the problem, they give you, they said the PE will have 2 events, right? It's 0.26. And the PF is equal to 0.41. And also they tell you P, the E intersect F is equal to 0.16, okay? I typically like to do those type of the problem by using the Venn diagrams here. All right, so let's take a look at the part A. They want to find the E union F. E union F, you don't have to do the Venn diagram. You can just use the addition rules, right? So it will be the PE plus the PF and the minus the PE intersect F, right? So this one here is just 0.26 plus 0.41 minus 0.16, right? Okay, so then this one's here will just be 0.51. So this one is kind of pretty straightforward. This one you're just using what? Use the additional, you just use the addition rule, and for the addition rule, this is the formula, right? The union is equal to, right? So you can just directly plug it into the formula. Okay, so the next ones here, I think it will be a little bit easier if you use the Venn diagram. Okay, so now is E prime intersect F. So let's do a Venn diagram here. Okay, so let me put the E's, let me give different colors here. So this is E, and then I will have this is F. Okay, so the first, let's take a look. Because, right, so because E intersect F is 0.16, so I know this part is 0.16, right? This is the common part. And so the 0.16 is in this common part. E is 0.26, but I already have a 0.16 here, so the remaining part here is 0.1, right? Then for the F here, you know, the total F is point what? 0.41, right? But the common part is already is 0.16. So how much left is inside here? How much? This is 0.25, right? So if you see my color codings, right? So it's 0.25 plus 0.16 will give you the whole big circle of the F. Then the 0.1 plus 0.16 will give you the whole big circle of the E's, right? Okay, now let's take a look here. Now I'm going to find is E prime, right? So I'm going to find the E primes here. So what is the E primes here? E prime is everything outside E. So everything outside E. So this will be my E primes here. Right? The yellow part will be my E prime. Right? So now the E prime intersect F. F is the whole thing's F here, right? So E prime intersect F. F is here, is this purple one. So this is the E prime. Okay, so F is this purple one. Okay, so which part is the intersection? The intersection is what? Which part is? There is here, right? It's this portion, right? So that's the intersections here. So by the Venn diagram, so I know that little pieces here is 0.25. Okay, so that's why I say in this type of problem, if you use a Venn diagram, probably it's a little easier. Now let's take a look at the next ones here, right? So this is the E prime union F prime. All right, so E prime union F prime. So I'm going to repeat this Venn diagrams here. Okay, so let's use the same color. So this is the E, right? So this is the E, and this is the what? This is the F, right? And the intersection part is 0.16. So this part is 0.1, and this part is 0.25. And last time we did not, for the last one, we did not do the sample size. Let's calculate what is the outside. The whole rectangle is 1. So it's 1 minus 0.1 minus 0.16 minus 0.25. So the whole thing's outside is 0.449. Okay. So let's write here. So the whole thing's outside is 0.49. Okay, so if you add everything, should add up to the, there's 0.49 plus 0.1 plus 0.16 plus 0.25. So it should add up to 1. Okay, now let's try to see which part I'm looking for. Okay, so E prime. Okay, so let's do the E prime. E prime is everything outside E. Right? Then the F prime, okay, so what is the F primes here? So the F prime is everything outside F, right? So the everything outside F. Let's do this. Let me make sure we can everything outside F. Okay, so if you take a look at this graph, now when we say E prime union, that means you combine the yellow color and the light blue color whenever it goes. So if you look at this diagram, which part doesn't have any of the green, any of the yellow and the blue? It's like the little middle one, right? So it's a 0.16. So that's why this answer is 1 minus 0.16. So it's a 0.84, right? Because the union, that means whatever the blue color, light blue and the yellow, that means the union. So if you look at the whole diagram, so everywhere is either blue or yellow. The only part does not have any color is that center part is 0.16. That's why the E prime union F prime will be 1 minus, right? Okay, so that's pretty cool, right? Okay. Okay, so now let's take a look at problem number 6 is here. Okay, so the problem number 6, let's go to the new pages here. So this is number 6. Okay, so the problem number 6, they said the data is gathered for the 130 adults U.S. worker. 55 were women. 3 women earned more than 40,000 and 62 men earned 40,000 or less. Find the probability. So when we try to do this type of the problem, it is better if we create a chart. So make the problem easier. So we'll say here, create the tables here. So the first ones here, we will say make a more than. So make more than 40,000. And here, the second one here is less than 40,000. Then we have a woman. And then we have a man here, right? So we have 2 things here. Okay, so in here, we say the total here. Total, we surveyed 130 adults, right? So we have 55 women here. So how many men I have here? How many men I service here? Is 130 minus 55, right? So I have a 75 here. Right, so even the problem did not tell you, but you can say, oh, the total 130 I'm survey, and then, I have so if I have a 55 women, so I will have a 75, excuse me, 75 men, right? Okay, so now let's read again. So they say 55 women, 3 women earned more than 40,000. So out of the 55, here, 3 of them earned more than 40,000. If 3 out of 55 women earned more than 40,000, how many with less? Will be 52, right? Okay, so the same way is here, right? So the men's here, right? So they said 62 men earned less than, all right? So 62 is here, earned less than. And now, if 62 earn less than, that means I have 13 earn more than, right? Then I can add here also. So I have 16 total will earn more than 40,000, and this is 114 is earn less than 40,000. Okay, so now the problems will become easy after we have this table. Okay, so let's take a look, right? Part A. Let's say if we choose one person, is a woman earn 40,000 or less? Is a woman earn 40,000 or less? So what is here? Is this, so I have 52 out of 130, right? So that if you want to simplify that, you can simplify. or you can just leave like that. So this is 2/5. 52 over, yeah, so this is 2/5. So it's 40%, you're going to pick a woman, is less than 40,000. Okay, part B is here. A man earn more than 40,000. What is the chance you pick a man? So it's 13 over 130, right? So earn more than 40,000, right? So these are about 10% of the chance you will get a man, right? So earn more than 40,000. Part C, you choose a person, is a man or is learning. Okay, so it's a man. So remember, when we talk about it here, we said this is a man, or right is earn more than. Okay, so remember we said we want to watch the keyword here. So this is or, right? So or we said the keyword is what? Is unions, right? That means I want to find a union. So basically I'm finding the probability is the man, or so it's a union more than 40,000. Then by the addition rules, I would say this is the man, PA plus PB plus more than 40,000 minus the probability of man and intersect, right? And more than 40,000. Remember the here, right? Intersections, that means the what? The keywords is and, right? So now let's try to plug the number. So what is the chance you will get a man? Is 75 of 130. What is the chance you will get anything is greater than 40,000? Greater than 40,000 is overall is 16 over 130. Now, what is the probability a man and 40,000, man and 40,000 is here, right? So that's why you minus 13 over 130. So you will get 78 over 130. So if you want to simplify that, you can simplify it. So it's 3/5 here. So that means you have about 60% of the chance you will get is a man if you randomly pick one. Okay. So then the part C, part D here is a woman or less than 40,000. Okay. So we use the same thing. That means this is a probability of a woman union less than 40,000. So that will be probability of the woman plus probability less 40,000 minus probability of the women intersect less than 40,000, right? Okay. So now women, so total women have 55 over 130. Total less than 40,000 is at 114 less than 130. Minus women and less, right? So it's here, women and less, right? So it's a minus 52 out of 130. So what I have here is 118 over 130. So let's see what is 118 divided by 130. It will be 59 over 65. So 59 over 65. It's a pretty high chance, right? If you randomly pick a person, it will be a woman or, it's less than 130. So that is the problem number 6. So the things here, we talk about is catch those keywords, right? So because these ones here, they say or, that means you need to use unions, right? And then because then you use addition formulas, right? So from here to here, that's what we call this addition formula, right? To find the unions here. Get it? So it's pretty cool, right? So it's kind of like okay. So now the next ones here, number 7 is similar. I have a tables here, right? So here this is number 7, okay? Okay, the number 7 tell you the table below lists the number of the head and the neck injury for ice hockey players and exposed when wearing either a full shield or half shield in the hockey league. Find the following probability. So here we are looking for the keyword, right? So they say to find the probability randomly select a hockey player with neck injury, given that the player exposure to wearing a half shield here. Remember the given, every time we see given, that means the conditions, right? So in here we said, I'm looking for the probability this player with neck injury. Given that, right, the player is wearing a half shield. So do you remember the formula? The probability of A given B, right? So remember this probability is the probability of the A, probability of A intersect B, right? So intersect means N. Okay, so right now in here I say, okay, I can reapply the conditional probability. So my denominator will be the probability the hockey player will the half shield. Right, so then the top will be the neck injury intersect half shield, okay? Now we just need to go to find the where. So remember this intersections, that means what? That means end, right? So that's end, right? And a while ago, we decided this line. That's why we read the problem, we see the keyword given. Okay, so now let's take a look. If you look at the table, the half shield, total, I have 115, right? Total have 115 out of 148. So this is 115 out of 248. This is the probability I'm going to, everybody will have shield. Now let's take a look at neck injury and half shield. That's the cells cover the neck injury and half shield. From the table, I find it's 40. So the chance is 40 over 248. So now this one is 40, 248. I think we all know how to simplify those fractions, right? You just flip it and the 115. So the answer is 40 over 115, okay? Okay, so now let's take a look at part B here. The part B is here. Find the probability randomly select a hockey player will have shield, given that player is with the, given that the wearing the half shield, given that the player with full shield. Okay, so let's see here. So okay, so this is a given that the player wearing with full shield. Right, so here you will have the probability of the full shield. Okay, so here, this is a half shield. And full shield. Okay, so the total full shield, I have 133 out of 248. But the half shield and the full shield, you cannot wear the half shield and the full shield together, right? So the chance is 0. There's no such thing as both half shield and full shield. So the probabilities here is, it's 0. You cannot say, hey, I give you is a full shield and then you wear the half shield. Okay. Okay, so now the part C here is I want to find the probability of randomly select a hockey player with the concussions or wear the half shield. Okay, so you see, oh, I see a keyword here, or, okay, when I see this keyword, I know they want unions, right? So let me rewrite my problem into union. That means probability of a concussion, union, half shield. Then, by using the addition rule, I can say this is the concussion plus the probability of the half shield. Then minus the probability of a concussion intersect the half shield. Right? That's just addition rule we have been using many times. So as usually you see, this is the keyword intersection. That means and, right? So it's a concussion and a half shield. Okay, let's take a look. How do we find the problems here? So concussions, so how many concussions we have? Total is 48. So it's 48 out of 248. How many people wear the half shield? 115 over 248 minus concussion and the half shield, right? Concussion and the half shield is 15 people, right? So you minus the intersection. So let's take a look at what we have. So it's 48 plus 115 minus 15. So it's 148 over 248, right? So it's 148 over 248. So divided by 248, I got a 37 over 62. Okay, so that's the problem number 7 is here. So I think we're going to stop it here. So the problem 7 is C. You'll be able to catch those keywords, right? If you see a given, that means it's a condition. You see a or, that means it's a union. Then you might need to use the addition rule to do that. So for this video, we cover 4 problems from 4 to 7. And I think let's cover the probability part, the conditional probability, and union intersections part. So right now, this will be a good place to stop. And so we are going to continue to the remaining of our problems here. Right? So we're going to do some counting, like a permutation, combination is the next, right? So hope you enjoyed the video, and I hope this video help you to solve some probability problems here. Well, I guess now is the time to stop, and I will talk to you later again.